Hello, welcome back to the channel. Welcome back to the video series where we are reviewing the Understanding Construction Drawings textbook. This is a final video of the series, and this is all about Unit 41, and that is electrical drawings. So this is quite a large unit, so please be ready to uh, just stay with me here for a little bit. I will guide you through. So in this unit, we will go through the information found on a lighting plan. Then we will list the equipment served by an individual branch circuit using electrical plans, riser drawings, and schedules. And also we'll get some information on a schematic diagram explained. So let's begin with just the electrical drawings and plan views, power circuits, light and circuit symbols, and so on. So the four basic methods of showing electrical circuits are plan views, single line diagrams, riser diagrams, schematic diagrams. And knowledge and understanding of the basic circuits used in buildings is necessary for those working with and interpreting electrical drawings. So let's move to the first one, and that is the plan views. So the electrical floor plan of a building shows all the exterior walls, interior partitions, windows, doors, stairs, cabinets, and so on. So basically all the furniture, fixtures, and equipment, along with the location of the electrical items and their circuitry. So where actually they are connected and what electrical and light fixtures, the outlets, and the switches actually switch on. So as far as the power circuits go, the power circuit electrical floor plan shows electrical outlets and devices and includes duplex outlets, specialty outlets, telephone, fire alarm, and the like. The conventional method of showing power circuits is to use long dashed lines when specified to be installed in the slab or underground, and to use solid lines when concealed in ceilings and walls. Short dashed lines indicate exposed wiring, and solid lines are often used in commercial installations when the raceway or conduit is to be exposed or surface mounted. Slash marks through the circuit lines are used to indicate the number of conductors. Full slash marks are the circuit conductors. A longer full slash is the neutral, and half slash marks are the ground wires. When only two wires are required, no slash marks are used. So the typical wire size for commercial construction is number 12 AWG, or American wire gauge. The arrow indicate home runs to the designated panel, and the panel and circuit number designations are adjacent to the arrowheads. The electrical installer will normally group home runs in the raceway with combinations similar to the following. So three-phase systems with three circuit wires and a common neutral in the raceway, and single-phase systems with two circuit wires in a common neutral in a raceway. Again, please refer to the textbook. You can see that all graphically represented here. And please note that in order to reduce the harmonic problems caused by solid state devices or non-linear loads, many electrical designers are required separate neutrals with each phase conductor. Also, some equipment such as TV, fire alarm, clock, PA, and sound may not be connected with wiring lines on the plan. This indicates that wiring for that equipment is not part of the general circuit wiring and is probably not to be fed through the same panels as the rest of the electrical equipment. And we are moving to the lighting circuits. There's usually a lighting circuit electrical floor plan for each level or major space within a building. And this floor plan shows light fixtures, emergency lighting, security lighting, and special lighting control, such as photocell and motion detector, and so on. And typically included in the RCP or reflected ceiling plan. And that is uh, uh, that shows what is on the ceiling as though it were reflected onto the floor plan. So as if you look at the ceiling plan from above, and it's not like you look up and see what is actually on the ceiling. So the lighting circuitry on the school edition, this is the set of plans that is included with the textbook. It is shown with 3 types of wiring circuit lines: solid for unswitched, dotted for switched, and line dash line for the motion sensor circuits. Also, the conventional method of showing light in circuits, it's the same as previously explained. So basically, it is going to be reflected on the RCP. Motion sensors are an interesting feature of the lighting design, and the motion sensors are shown as small circles containing the letter M. A motion sensor detects any movement in the area of the sensor so that in the room controlled by a motion sensor, if there is no movement in the room for a period of time, the sensor opens its contacts, like turning a switch off. A motion detector can be used together with a switch so that the lights are controlled normally by the switch. But if someone forgets to turn the lights off, the motion detector will. And probably you encounter that in the bathrooms or some other hallways that are not frequently in use. A low voltage lighting control system requires a relay that is activated by the switch, and the relay opens or closes the higher voltage fixture. The relays are indicated by letter R in a small square, and you can notice that every lighting switch is connected to a relay. So that's an interesting feature here in this set of drawings. Let's talk a little bit about the symbols. So electrical symbols are used to simplify the drafting and later the interpreting of the drawings. Electrical symbols are not standardized. Again, throughout the industry, there are no standards. Most drawings have a symbol legend or list, and you must be knowledgeable of the symbols specifically used on each project since designers modify basic symbols to suit their own needs. Many symbols are similar, such as a circle or a square, and the addition of a line, dot, shading, letters and numbers and so on give the specific meaning to the symbol. So learning from the basic form of the various symbols is the best starting point in developing the ability to interpret the drawings and the irrelated symbol meanings. So again, please refer to the textbook. There are a few symbol legends here and you can learn from them. So that is a really good starting point. The installer must request clarification or direction and give the designers reasonable time to clarify the questionable specified instructions. So if something is not clear just because there are no standards, the architect can expect an RFI or a request for information and then clarify the question. Let's move to the single line diagrams. So the electrical service single line diagram is brought into the project, into the building by way of the service entrance section or SES. The note coordinate with local utility requirements prior to rough-in indicates that the electrical contractor is to furnish and install the 3 4-inch conduits and that the utility company wants to inspect the conduit installation prior to backfilling the trench where the conduits are installed. However, this should be verified at a pre-construction meeting with the utility company. There are times when an electrical service or electrical distribution raceway would require being concrete encased for protection. And this type of concrete encased underground raceway system is called a duct bank. So there is a detail showing the duct bank system. You can see that here. And in order to comply with the National Electrical Code, or NEC, the service entrance section may have up to 6 main disconnecting units, switches, or circuit breakers. 4 main fuse switches are shown in the existing portion of the single line drawing. And please note that this single line drawing shows only portion of the complete existing service entrance section. The service entrance section indicates that it is located outside by the NEMA NEMA enclosure and Natural Electric Manufacturers Association, or NEMA, generates specifications that are recognized as design standards for electrical boxes, devices, and equipment. The new portion of the single line drawings show the electrical distribution to be installed in this school edition, and please refer to all the drawings. There are the new electrical loads shown here. Please take a look and you will see all the details here. It's too long to highlight that in the video, but if you're interested, there is more information there in the textbook. So let's talk a little bit about the riser diagrams. A riser diagram is so named because it usually shows the path of wiring or raceway from one level of a building to another, and because the wiring rises from one floor to the next. A riser diagram does not give information excuse me, about where equipment is to be located in the room or area. Riser diagrams are used because they are particularly easy to understand and do not require much explanation. A power riser diagram shows a typical building's electrical service and related components. So a special riser diagram is used for many systems that include fire alarm, security, telephone, clock, signal such as bell, call like emergency call or nurse call, and water sprinkler. So the fire alarm riser diagram shows that the fire alarm system uses the 3 1/4-inch conduits to ramp area. And also these 3 conduits are to be used with the fire alarm connection to the existing fire alarm system. And the original fire alarm control panel was sized to accommodate the new addition, but also the drafters and the contractors should verify that the existing special systems will accommodate the additional requirements when adding to or modifying the existing systems. And again, please refer to the diagrams shown here. And the telephone riser diagram shows an existing 1 1/4-inch conduit, 150 feet in length, and from ramp area to the existing main telephone terminal cabinet. And again, there are more details. If you're interested, please take a look at them. Schematic diagrams. A schematic wiring diagram is a drawing that uses symbols and lines to show how the parts of an electrical assembly or unit are connected. A schematic does not necessarily show where parts are actually located, but it does explain how to make electrical connections. Several of the schematics show connections to wires, and there are labeled G, N, and H, and these stand for G for ground, and for neutral, and H for hot. So schematics are commonly drawn for electrical equipment that involves internal wiring, such as washing machines and all the way to computers. The starter control is taken from phase one through a stop push button and a start push button paralleled with a latching contact M to the starter coil M. And you can see that in the drawings. Let's move to the schedules. So an electrical schedule is used to systematically list equipment, loads, devices, and information. Schedules organize the information in an easily understood form and can be a valuable method for communicating the design requirements to contractors and their installers. The fixture schedule lists complete information about each fixture type shown on the lighting plan. And usually it's shown on a fixture schedule. So mark, that label is used to indicate the fixture type. The mark is written on or next to each fixture on the plan. Then make, the identification of the manufacturer used to establish the specific design requirements needed to aesthetically and functionally light the various rooms or areas. And then volts, it is actually now common for light fixtures to be powered by up to 277 up to 480 volts, while the switches made while the switches might use only 24 volts, and that's low voltage lighting control to protect the person using the switch. Watts, it is necessary to know the wattage of the lamp or a bulb in each fixture so that the space will have the amount of illumination intended by the electrical designer. Lamp type and quantity. The lamp manufacturers have similar systems of designing lamp characteristics. Also, notes or remarks are really important too. And you can see this column is for information that does not clearly belong under other headings. So basically, whatever is left, all the miscellaneous stuff is here under the remarks section. Again, refer back to the drawings. You can see the incandescent lamp designations. You can see a fixture schedule. You can see fluorescent lamp designations and compact fluorescent lamp. You can see other things here. So a panel schedule identifies the panels by their mark or label, and they are shown by this same designation on the electrical floor plan. The panel schedule lists each of the branch circuits served by a panel, the circulated load for that branch circuit, the voltage of that circuit, and the number of poles and trip rating for each circuit breaker. A panel schedule also might include type, surface or flush, then panel main bus amperes, volts, and phases, then main circuit breaker main logs only, then breaker frame sizes, items fed, and or remarks. Also, on the lighting and power plans, we can see that each device is connected to a branch circuit identified by a panel number or label and circuit number. those numbers correspond with the numbers on the panel schedule. And here you can see the kitchen equipment schedule. You can see the receptacle schedule, and that is also valuable when a number of specific receptacle types are found on the electrical drawings. If there is no receptacle schedule, you should make one to expedite the installation time required and reduce the chance of installation error. And usually the receptacle schedule should include the symbol designation, then amperage, voltage, NEMA type, number of wires and poles, the configuration of the blades or slots, then manufacturer catalog number, and also some other information like duplex, single, or three-phase, and so on. And also the connected load schedule can include the type of load, building or area designation, size of load in kilowatts or horsepower, so it depends, total electrical load by type or area, and notes explaining any special methods used in the load circulations. We are approaching the final sub-chapter of Unit 41, and that is specifications. We described it many times in the previous unit, so if you are interested, please go back and check some of the part 1 videos. You can see them in part 2, and yeah, so we've discussed the specifications many times, but I would like to still mention it here that the drawings and the specs are the items that establish the intended design and the construction requirements required by the owner, architect, and engineers. The contractors and their installers must review the contract documents for conflicts and or discrepancies between the contract, the specs, and the drawings. And sometimes the contractor notices the discrepancy with the code if they are familiar with the authority having jurisdiction. Sometimes the code is already the new version and the drawings were prepared in the previous version. And if there is like a large discrepancy, the whole set must be redone. The drawings should be reviewed for conflicts between sections, such as architectural, mechanical, plumbing, structural, civil, HVAC, electrical, and so on. So now with the BIM system, it's a little easier when you just plug in the program that actually detects the errors. That's a little easier, but yes, you need to know where to look to identify those errors and mistakes. The drawings should still be reviewed for conflicts sheet by sheet. And the electrical specifications give the quality of materials intended to be used and the installation and testing requirements. Sometimes a specific manufacturer or a catalog number is specified with no substitution or equal allowed, and that's the closed spec, and that does not allow any competition, as we already know. This usually inflates the cost of the project, and there is no standard specification at the same time. So it totally depends on the project, it depends on the owner and other stakeholders. And the contractors and their installers should read through all project specifications and become knowledgeable of their content prior to starting any installation. So that was it, my friends. We are done with all 41 units of the Understanding Construction Drawings textbook. Thank you so much for watching. Thank you for staying here with me. I wish you the best of luck in all your new endeavors. Goodbye.